Hello learners, we now come to the second nutrient under the category of non-nutrient effects of specific nutrients, that is the role of peptides in human health. Now the role of bioactive peptides in human health is discussed in this module. The different methods of obtaining peptides from plants and animal sources and the regulatory requirements will be discussed. The use of peptides for increasing energy, burning fat, building muscle and improving athletic ability shall be dealt with along with traditional food sources. Recent scientific evidence suggests that food proteins not only serve as nutrients, but can also modulate the body's physiological functions. These physiological functions are primarily regulated by peptides that are encrypted in the native protein sequences. Peptides and proteins are both made up of amino acids. Roughly speaking, anything under 50 amino acids is a peptide, while anything larger than 50 amino acids is a protein. These bioactive peptides can exert health beneficial properties and thus are considered as a lead component for development of nutraceuticals or functional foods. Now let us see what are bioactive peptides. Bioactive peptides are defined as peptide sequences within a protein that exert a beneficial effect on body functions and or positively impact human health beyond its known nutritional value. These peptides can regulate important bodily functions through their myriad activities, including antihypertensive, antimicrobial, antithrombotic, immunomodulatory, opioid, oxidant, antioxidant and mineral binding function. These are also used for the development of nutraceuticals or functional foods. Now, the sources of peptides include an array of plant and animal food proteins that have been used for extracting bioactive peptides. The most widely used animal proteins are from eggs, milk, that is casein and whey, and meat proteins. Bioactive peptides from plant sources are typically from soya, oat, pulses that include chickpea, beans, peas and lentils, canola, wheat, flax seeds and hemp seed. Furthermore, proteins from marine sources have also been used, for instance, fish, squid, salmon, sea urchin, oyster, seahorse and snow crab. Let us see what are the methods of production of bioactive peptides. Now, bioactive peptides from food proteins can be produced either by enzymatic hydrolysis using proteolytic enzymes from either plants or microbes, hydrolysis with digestive enzymes which is stimulated by gastrointestinal digestion, or by fermentation using starter cultures. Some studies also used a combination of these methods to produce peptides with a biological activity. Furthermore, bioactive peptides can also be synthesized chemically, as the amount of these peptides found in the nature is very low and there is a constant increasing commercial interest of producing synthetic bioactive peptide. The classical approach of producing bioactive peptides is to find a suitable protein source, followed by its hydrolysis using either enzymes or by microbial fermentation, so as to generate peptides with a potential bioactivity. This would be followed by the identification of the peptide sequences and confirmation of the bioactivity. As these peptides are derived from food, they are generally considered more natural. Hence, perceptions of acceptance are likely to be higher. Yet, their use as orally ingested products also presents special challenges and consequences. Now, we move on to digestion and absorption of bioactive peptides. The oral intake of food and medicinal products is fundamentally dependent on taste. Taste is often the body's first response to an orally ingested substance. As such, it is vital for orally taken products to have a favorable taste profile. Protein hydrolysates and individual peptides often fail on these grounds, as a significant number of these products are bitter, which may limit their acceptability. Absorption from the gastrointestinal tract is essential for a bioactive peptide to exert any systemic biological action downstream. Traditionally, it was believed that all peptides and proteins were digested down to their constituent amino acids, and only these amino acids were capable of absorption across the intestinal epithelial barrier. However, it is apparent now that many peptides do cross the intestinal epithelium under normal conditions and enter the circulation and exert their systemic effects. The absorption of intact peptides, either alone or as part of a protein hydrolysate, is an exciting area of research that is critical for the successful oral use of these compounds, and examination of the specific mechanisms and therapeutic approaches in greater detail is required. A larger number of food peptides have already been validated for their anti-inflammatory and antioxidant properties, which make them either alone or in combination theoretically well suited for management of irritable bowel disorder cases. Now, let us see what are the health benefits of peptides. Bioactive peptides are obtained from food protein and are purported to have health benefits. If a product is taken as a food, that is, the primary use is to gain sustenance or nutrition, it should be considered as a food. On the contrary, if it is used to mitigate a disease or improve a bodily function, then it is a drug. Across different cultures and constituents, people have used foodstuffs like yogurt, cheese, kefir. These are all milk protein derived peptides. Pickles, these have peptides from fermentation of fruit or vegetable proteins, and fermented soybean products like tempeh, tofu and natto, which are rich sources of food peptides, many with well-known bioactive properties. Being widely known for their culinary use and regarded as safe to eat, these products have the least regulatory requirements. As long as these are prepared in a sanitary environment and use food grade chemicals like enzymes and processing aids, no special action is needed. While traditional and novel foods are widely sold, there are restrictions on health related claims pertaining to these peptides. Now, let us see what are the bioactive peptide supplements that are available. In the world of health and fitness, peptides are used for increasing energy, burning fat, building muscle and improving athletic ability. Peptides are used for athletes for their anabolic effects. Supplement companies often break proteins down into peptides as they are easier to absorb. Collagen is a good example. The body struggles to digest collagen proteins, but will readily use the collagen supplement. Peptide supplements, which are considered as performance enhancers, are known to mimic or influence the natural peptides in the body. Peptides can be either injected into the body or used as a skin patch. They can have potentially serious side effects, hence it is essential to consult a physician before their use. There are some regulations regarding the use of bioactive peptides. Let us see what these are. There are a number of special regulatory requirements for foods for special uses, which may involve those for medical conditions, example low energy, high energy and low in particular amino acids, or those intended for vulnerable population. The commonest example is infant formula for infants aged between 0 to 12 months. Most jurisdictions use stringent regulatory standards to protect the nutritional needs of infants. As such, it is one of the common regulated food sold all over the world. Globally, infant formula is regulated by Codex Alimentarius standards under the auspices of the World Health Organization and the Food and Agriculture Organization. Not all biopeptides are meant to be foods. Many are better suited for use as health products, which can be addressed under the natural product category. Thus, the potential exists for use of bioactive peptides with well-defined physiological roles to be incorporated into commercially available foods and drinks under this regulatory measure. The regulatory environment includes the laws, regulations and licensing systems that govern the manufacture, import, export and sale of regulated products. In the context of biomedical and food industries, it involves various aspects of foods, drugs and other products with effects on health and nutrition. Most advanced economies of the world have regulatory regimens that ensure the safety and, wherever applicable, efficacy of such products in order to protect the well-being of their citizens. Given the novelty and the potential health and nutritional roles of food-derived bioactive peptides and protein hydrolysates, it is critical to understand and engage with the regulatory systems in place in order to successfully translate the discoveries from the laboratory to the real world. Now we go to the challenges in use of bioactive peptide supplements. Now, the oral use of bioactive peptides and protein hydrolysis offer a number of unique advantages and challenges that require further efforts in research and development targeted towards different aspects such as palatability, digestion, sites of action and safety. The development of these peptides for health promoting and therapeutic purposes would have to take into account these factors when devising strategies for oral usage. It is also very important to investigate the impact of the coexisting food matrix on absorption of these bioactive peptides. Research is also required to evaluate the physiological efficacy of these food-derived peptides in human clinical studies. Such scientific knowledge will be helpful for the regulatory bodies to categorize these products, which would facilitate their commercial use to improve human health and wellness. A better understanding of the manufacturing, consumer-related and regulatory aspects would enable broader acceptance and faster utilization of their potential. We have seen, learners, how peptide is obtained from protein sources, from plant and animal foods, as well as the traditional foods which are good sources of peptides. The relations governing the use of peptides, especially in foods and drinks formulas used by athletes, have been discussed. The oral use of peptide offers challenges, and targeted research is necessary to evaluate its efficacy and safety. Thank you.